Welcome, everybody. It is SEMA Central right here. SEMA 2014. I'm Dennis Pitzenbarger. Sitting next to me, Tom Gillespie from CarSim, excuse me. And you've got a really neat kind of aspect on the way you approach the automotive industry. And I mean, for lack of better ways to put it, what is CarSim and what do you got going on?
CarSim is a vehicle dynamics simulation program. We come from the vehicle dynamics world. We write computer software that allows us to simulate how it accelerates, how it brakes, how it rides, how it handles, the rollover process, all of those things for cars, trucks, motorcycles. And so we have a tool that is very, very useful and is actually used by a major part of the OEM car manufacturers, Tier 1 suppliers, Tier 2, the government, and basically a pretty broad range of users.
Talk about what it is, because I mean, vehicle dynamics are so important. We've had a few of the guys up here talking about, with compliance with either regional or, global spectrum of what needs to be legal. It's so important to make sure that you're compliant with the rules, and I'm sure that you're integrated into that as knee deep as you can be.
Right. We're here at SEMA basically trying to help the SEMA members deal with what is a very complex world. Cars used to be mechanical. Now it's really electronic. The combination of mechanical and electronics, that thing that you may have known as mechatronics, there's a technical word.
That's above my pay grade.
In any case, when you put these together, it is a really, really complex system. And the real question is, you can look at the suspension. The SEMA members here are used to doing that, and visualize how to improve it. How do you look at an electronic box, figure out how to improve that? You need some way to be able to emulate or get a chance to try to figure out how does this thing behave before you know how to improve it. That's what simulation does.
So in a lot of ways, you're also not only helping them literally solve problems, but you're doing it without the cost of so much R&D in mechanical. You're doing it sort of in, I hate to say the word cyberspace, but you're doing it without the waste of materials and kind of forging ahead on the ability to engineer items.
Yeah, there's a lot of advantages. Of course, one of them is you don't have to build one and discover it doesn't work, right? You can do it in simulation and move on to the next item.
That can be a little frustrating for a lot of the guys. I'm sure there's a lot of guys with innovative products at SEMA that say, wait a minute, I could have built it without wasting the time, money, and materials.
That's right. There's a lot of other advantages to simulation too. A lot of it is, today it's safety. You can't afford to fool around with an electronic system on a car and take it out and drive it. You may have done something wrong, and I've known people run off the road because they didn't realize what they were doing. So there's safety, there's the advantage of being able to do it before you actually build anything, but also there's the really high expense of testing. It takes a lot of time, slows you down, and costs you a lot of money.
Give me an example of something that would be a product or an application that you guys would use. Again, to give a clearer picture, maybe to me and everyone else watching this, give me an example of how a product or a system that you would help use.
Okay, I'll go back to the electronic stability control issue you've been hearing about. Electronic stability control has these very specific performance requirements set by the federal government. If take a manufacturer of a car, you build a certain model car, and its performance depends on a lot of things, which tires you put on it, what wheels, what brakes, what engine, all of these options. And so you can go out and test one, but you can't test every possibility. Typically, one of the applications of using our software to basically certify a lot of variants on a vehicle, I counted 135 different combinations. Wow. That company would have had to test if they did everything by test. That's where we come in. Now,
when you're talking about vehicle like stability control, you're talking about obviously your ability to then give them results without testing on that parameters of yaw, pitch, when the car would slide. So it kind of gives them, it's kind of an upper hand in the ability to tune the car better without so much actual on-track time.
Yeah, and that's actually an advantage to SEMA people as well. If you get into simulation, you can go ahead and use this virtual vehicle to figure out how to do it better. and you can improve your product just by sitting there and imagining what you might do without having to build it.
Well, that's amazing. CarSim, Tom Gillespie, thank you so much for coming by and spending some time with us on the SEMA Central stage. If people want to know more about what CarSim is, get in touch with you, find out about it. How do we do that?
You can come to carsim.com. It's pretty simple to find, CARSIM.
You heard him, carsim.com. More from SEMA Central stage in a few minutes.